stream series on linear regression. We're going to be kind of reviewing a lot of the stuff that we covered in the last 7 weeks in one day. And we're just going to kind of play with the data set and really go through a full process from start to finish of how do we get some data, how do we clean it up a little bit, how do we fit some models, how do we compare them, and maybe we'll see if we can come up with the best possible model that we can for predicting rental prices by the end of this session.
Yeah, I think this session in particular is kind of more open-ended than our last ones. Basically, our plan is to play around with this data set, and so definitely if you're watching this in the chat as we are doing this live, and you want us to like take a look at any of these features or want us to experiment with this in a particular way, we are super open to making this as interactive as possible. So yeah.
Exactly. Yeah, we want this to be kind of a fun way to kind of wrap everything up, but also make it explorational. Is that a word?
Explorative? I don't
know. Okay, cool. So one thing I do want to point out before we get started is that if you're following along with the linear regression course on our site, and I'll go to Codecademy really quickly right now and pull that up. So if you go to this linear regression in Python course and take a look at the syllabus, the data set that we're using in a cleaned form exists in this last project in the course, this Craigslist analysis. So if you'd like to play around with this and you want to just get the data already loaded for you and see an example solution, this is a little bit subsetted and it's a little bit cleaned up, but you can do that here if you have a Codecademy subscription, and even after this stream, if you want to play with it yourself but you don't want to set up your local environment, this is a great place to come and play with it. Cool. So I'm just going to show you, I'm not going to go through the full process, but I'm just going to show you where I downloaded the data from. And the reason I'm showing you this is really just because if you're working on your own computer, you're doing your own analysis, you're just getting started, you might come to a place like Kaggle or the UCI machine learning repository that we've shown before, and you might download your own data set. And so I think it's useful to kind of see the process from the beginning. So this is the data set we're going to be working with. I found it on Kaggle just by going to kaggle.com, clicking data sets, and then searching around within data sets. I like to use data sets that have a high usability rating. So 10.0 is like the highest I think that you can get. So if you're just starting out, it just means it's really easy to download this data and get started with it. It's not super, super messy, although this is a pretty big data set and has some columns that you might not care about, but it's super easy to use. It's got like descriptions of everything. It's got like an overview. It's got easy download, all of that. So we can take a brief look at it even on Kaggle. We see there's 22 columns, 10 of them are printed out here. So you can get a sense for what kind of information might be contained in here. And then we can also get a little bit of context and information about how this data set came to exist on Kaggle. So it gives us the sentence, Craigslist is the world's largest collection of privately sold housing options, yet it's very difficult to collect all of them in the same place. So this person built this data set as a means by which to perform experimental analysis on United States as a whole, and instead of isolated urban housing markets. The data is scraped, so web scraped every few months. So somebody else has done all the web scraping for us, which is nice. It contains almost all relevant information that Craigslist provides on retail sales. So this is just data that has been web scraped from Craigslist about housing listings.
Yeah, the license is kind of interesting in if you're like making a project for your portfolio or something that you're making for your own personal projects, you might want to look at the license and just kind of like dive into what you're allowed to do with the data set. Obviously, if it's on Kaggle like this, you'll probably be able to like download it and play around with it yourself. But again, you might want to look at the license when you think about, hey, how should we be like publishing something related to this data set?
Yeah, exactly. Okay, so I think we can get started. So all I did was I pressed this download button. You have to create a Kaggle account. Oh, you can't see my mouse, but you can see that it's highlighted in the top right of this right-hand corner of this page. There's this download button, and you have to create a Kaggle account. Once you press download, it will download onto your computer. And then all I've done is I've moved this housing.csv file that was downloaded when I pressed that button into the folder where my Jupyter notebook is, or it could be the folder where you've got like your script that you're writing as well. And then I've just opened up this code.ipynb, this Jupyter notebook, and this allows me to start playing with the data.
Yeah, and again, if you aren't super familiar with how to work with Jupyter Notebooks, we've got a lot of articles that kind of help you set that up. It's slightly complicated to just like open the Jupyter Notebook to begin with. I'm assuming you did it through Terminal, or did you do it through like the Jupyter app?
I did it through Terminal.
Okay.
It's actually like once you have it downloaded, it's relatively simple to do via the terminal. I think you just type Jupyter Notebook into the terminal, but yeah, it definitely takes a little setup on your computer first before to get that running. And I think we provided some information on how to download everything on the first stream, I believe.
Cool.
Cool. So I'm just going to load a bunch of libraries. I don't know which ones we'll end up using. And then I'm going to go ahead and load this data. You'll notice normally I just do like this, right? Read in the CSV. But let's just print what that looks like. Oh, actually, seems like it's fine. I pulled this from somewhere else. You might notice though things that happen when you first load a data set. You might see like the header, for example, is getting pulled in as a row instead of like column names. And so that's what I was intending to do in that first line of code, but it looks like it's being read in okay, so that's fine. And I've used the Pandas library to read it in. And so I think a good goal for today is to try to come up with a linear model that allows us to predict price. And in the process, we can start thinking about what the relationship between price and some of these other variables is. So type of apartment, square feet, beds, baths, but also all this other stuff. We've got like parking options, laundry options, comes furnished. So we got like lots of information. And then we're going to see if we can figure out the relationship between all of those things and price and see if we can predict price accurately. And maybe we would be doing this if we are renting an apartment ourselves, or maybe if we are the owners of an apartment and we're trying to figure out like what is the best or the appropriate market value for this apartment. Okay, so let's take a look at a couple of things. If we're trying to build a linear model for price, are there any columns that you think we should get rid of, Alex?
So there's all this kind of like metadata information, like the URL, the ID even. I don't know if we necessarily need that. It looks like all of these are from Reno/Tahoe, so like region URL, it seems like it's already represented in the region column. So I would probably get rid of region URL. That's all I would get rid of from what I'm seeing here. There might be more things to the right if we keep looking, but
So let's actually, we'll print out the info so that we can see, first of all, how many rows and columns there are and see all the names. Looks like, so we've got around 385,000 rows, so a fair number of rows, and then 22 columns. We saw that before. I agree that it makes sense to get rid of some at least ID and URL. It looks like ID, for example, is being read in as an integer. So we're thinking of this as like a numerical value, but like an ID that is a higher number, like this is a higher number than this, I believe, if I'm looking this correctly. But no, I have to go back further. This bottom one actually is a larger number than the one above it, but that doesn't really mean anything meaningful about this apartment with respect to this one. It doesn't mean like it has more of something. It just means that it has a different ID number.
Yeah, this might even be a good example of something that are like not correlated at all, and so would not make for a good linear regression. Where if we mapped like price to ID, the ID is just kind of like a randomly generated number, presumably, or at least that's what I'm assuming, and so we wouldn't really see any relationship there.
Yeah, and then for URL, I mean, I don't want to do it because I don't want to like create a problem. Well, we can do it on a smaller scale, but what would happen, Alex, if we just like put URL in? It looks like it's being saved as a string.
Right.
If we added URL to our linear model, what do you think would happen?
I mean, so I think that would try to break it. That would consider that a like categorical variable, right? Of like, hey, there are 700 categories and none of them share, category 1 is this URL, category 2 is this URL. So it's just 700 categories and they're all different because none of them share the same URL, presumably.
Yeah. So let's actually do this really fast because I think this is kind of a funny exercise. Let's start by just making a smaller subset of this housing data where we'll just take I always forget the syntax here. Is it like if you just want the first couple of rows? It's on iLock, and then you do like...
I think it's like 0 to 0:5. We'll give you the first 5, I think.
0 to 5.
I think. Let's see.
Cool. Okay, so let's do 50 rows. And then let's fit a model. I'm going to actually grab my... I'm going to grab some code from somewhere random. Again, because I never memorize these things.
So I think breaking down this line of code real quick. So we are using the SM module, which if we look at our import statement is statsmodel.api. And then within that, we are using, if you scroll back down to your line of code, within that we are using the OLS. What does OLS stand for? Do you know?
Ordinary least squares.
Okay.
So this is, remember at the beginning, we kind of talked about ways of fitting linear regression model. And the way that we've been using is called ordinary least squares because we're minimizing the squared distance between each point and the line, essentially.
Okay. And then we're saying we're building it from a formula, and that formula is what? Based on predicting price based on URL.
Yeah. And I'm going to use housing underscore sub. And then I'm just going to print model1.params. And so how many parameters do you expect to see?
I expect to see 50 parameters because it's because again this is the example where they're using URL as a category and there's presumably 50 different URLs, and so
yeah I think there might be there's going to be 50 unique URLs and then minus one reference group,
right?
So 49 plus a intercept. So yeah, you're exactly right. There's going to be 50 of these. And we end up with, so here's the intercept, and then you see we have a slope for URL true dot this whole thing, URL, and then we have a different one for URL true dot this whole thing, and then it keeps going, right?
So pretty good example of if you just like take your data set without thinking about it, you're going to run into something like this where suddenly we have 49 parameters based on these random URLs, and that's definitely not what we're interested in doing.
Yeah, and this is actually one of the things that so we can talk a little bit about this if we have time a little later today, but I think a lot of times people end up using other packages. I think the most common one is scikit-learn to fit models. And when you fit a model in scikit-learn, you can get these like parameters, but they don't come with labels automatically. And it's a library that's really built around like building the model and making predictions, not necessarily like inspecting the model output. And so I think that one of the reasons I like stats models is that if I were to print out like just the standard model summary here, like it's gonna give me, I'm gonna have to like see that something crazy happened here. And then that hopefully gives me a clue that I need to like be more purposeful about my model. And it's not always the diagnosis that has to happen isn't always like, it's not always really detailed and small. Sometimes it's like a big mistake like this where you just threw something into a model and it didn't make sense, but you weren't thinking about it necessarily before. So
yeah, we have a question on the Facebook page of how do we deal with those categorical variables. We touched on this in much greater detail in an earlier session, so take a look at our YouTube page, and if you look at this series, you'll find videos about dealing with categorical variables. But do you have like a quick answer of like how would you deal with something like this?
Well, so you can definitely include categorical variables in your model, but you need to be a little bit careful about it because depending on how many possible values there are of a particular variable, you could end up with a whole lot of parameters in your model, which means you have to estimate a lot of things, and you've now created something that's super complicated that may or may not really be improving the model. So in our last session, we talked a little bit about like what's the trade-off between like accuracy of a model or predictive ability of a model and like complexity. And I think depending on the problem, there's maybe a different balance. There's no right or wrong answer. But I definitely think like there's a limit to how much complexity you potentially want in your model. So we'll talk about that a little more today too.
Yeah. So I'm curious and this is maybe a tangent, but in looking at the URL, and then I was also curious about the column description. Can we scroll over to see the description on some of these just to get a sense of like what those look like? What would you think of doing something like creating a new column that's like, is the word stunning in either the URL or the description, right? Could we do some like natural language processing of taking this information that's in paragraph form or natural language form and trying to create new categories like that? Or like,
definitely.
Imagine, washer dryer is already a column in here, but let's say that column didn't exist. Could we look in the description and try to like create our own variable of like, oh, the description mentions a washer dryer?
Totally. Yeah. So that's a really good point. A lot of times in your data pre-processing stage, you might like right now, I think for time's sake, we'll probably just get rid of this description column. Although we could probably relatively quickly write some code to pull something out from here. But yeah, for sure, there are definitely places where you can take data that exists in a format that you're not going to use. Like you're not going to throw description into your linear model and turn it into usable information. Like I like your example of if the word stunning is in here, like maybe Or I'm trying to think of another thing.
Yeah,
that
I was
could
looking.
be-
I was thinking of that when I was looking at the URLs. If you scroll down to, or maybe you got rid of it at this point, but if you look at those URLs, which were showing up in the when you were showing all of
Okay.
the parameters, but the URLs are like Craigslist.org/stunning-bedroom, like 3-bedroom.
Yeah.
So I was thinking, oh, like there's information in those URLs that even though we don't want to use the URLs themselves as categorical things, we could like maybe parse those URLs to get some information out of them.
Yeah, or maybe like ocean view or something like that
Yeah.
that people want.
Oh,
Yeah.
interesting comment in the YouTube chat from Alex of you could just get the length of the description as a column.
Yeah. What if I do len description? Is that going to give me the number of characters?
Yeah, I think so. Assuming it's just a string.
Let's actually we can try that. Before we do that though, let's go back and let's actually like pull out some of these things. So I feel like we can safely say the ID column is probably not giving us any information towards price. I'm going to get rid of URL as well because I figure anything that's in the description is probably in the URL. Also, I'll get rid of region URL like you said because that information is also contained in this region variable.
Image URL number 17 there probably isn't super helpful.
Okay, yeah. And then we can leave lat and lon. I assume those are latitude and longitude, which might be interesting. So let's go ahead and start with that. So actually, let's think. Should I use, I think there's like a dot drop that allows us to easily get rid of columns, or we can use subsetting. But let's see if I can find this. Drop columns. I'm gonna just show you guys my Googling as well because I feel like this is a useful skill indeed. Okay, so this is the labels parameter gives the index or column labels to drop, and it looks like I can just input like a list of labels that I want to drop. So I'm going to go ahead and grab those. So we've got ID, URL, region URL.
I wonder if it does it in place or if we'll have to do housing equals housing dot drop.
You are probably right. Let's check. And then was there anything else? Image URL maybe?
Mm-hmm.
Okay. Was it IMG or
Full
image URL? Okay, let's see. This might just give us.
Maybe it takes index of 0, 1, 2 instead of the column names.
I'm gonna try labels equals this. And
we might need to give it an axis.
Okay. From the index or the column. So let's give it axis equals 1 because we want to drop the columns.
Mm-hmm.
Okay. And then this just gave us this exact same data set, but with those columns dropped. And so now if we want to resave it, we either need to add in place equals true or housing equals. So I'll do it this way. And then let's just see. So if I take len of housing dot description, is that going to just give me a bunch of numbers?
So, interesting. I bet that's like the sum total of the description. I'm guessing you want a column, right?
Right.
You might need to do like an apply of like, or housing of description of the column. Let's see. Right, so let's just get the column, right? Housing.description of, oh no, that is what, that is.
That is
housing,
what,
yeah.
yeah. So let's try apply function to a column in Pandas. I know that's the dot apply, but I just want to pull this up so we can see it. So this allows us to apply the same function to every value in a column. So axis along which the function is applied. 0 would apply it to each column, or 1 apply the function to each row. So if we want to apply to each row, we would set that equal to 1. So let's try this as well. Let's do like housing dot, and then
I see on YouTube someone's pointing us to dot shape as well, which might be a good way to do that. I'll look into that as you work on apply.
Okay. Well, let's see. This is going to apply it to every column. So I wonder if I can just pull out like housing dot description dot apply, and then do like,
and give it lane as the function.
len. I
would just give it len, and then we have to figure out the axis stuff, but. One takes no keyword arguments. Interesting. Let's see.
If I do like len of hello, I am Sophie. It does give me the number of characters. Let's see.
So if we get just the column, so if you do data frame, or so if you do housing.description dot s dot len
dot s dot len
dot string, sorry, dot str dot len
dot len, and get rid of,
yeah, and then parentheses after the len as well.
What does the str do?
Wow. I believe it was saying treat it as a string. We can try to get rid of it. We can try to get rid of .str and see what happens.
I think we had applied, no. Interesting. Okay, so if we apply len to the entire series, then there's no way to calculate the length of a series object.
So we need to turn the series into a string or something.
A set of strings.
Yeah.
Super interesting. Was that your own Googling, or is that?
Yeah, so I Googled panda get length of string in column, and it was the first result.
Nice. Okay. Well, I wish you guys could also see Alex's screen, but this is fun. Okay, so this gives us the length of the description. Let's add this into our initial data set. So we'll say like housing dot description length equals. It's gonna give me a warning, but it's gonna work. Let's go ahead and take a look at housing.head again.
Yeah, probably good to verify that this is doing what we expect, where we have description, and then description length is probably all the way at the very end.
I didn't see it actually.
Oh, did you reset housing equals
Let's try this again. But I don't think. Oh, there it goes. There it is. Okay, so now we've got a description length, the number of characters. And then I'm gonna now drop description. I don't think we're gonna use anything else. But again, like Alex said, we could do something else here. We could figure out, we could pull out some word that we think is gonna be associated with particularly high prices, like exceptional or special, maybe like places that have some sort of 1 free month special are more likely to be
recommended. We could even look for like free month in there, because I think that's not a data that's represented in any of our other columns. Like, oh, this comes with a free month. Well, that like changes the real price of the apartment.
Exactly. So we could definitely pull some things out of here and create some more columns around description, but I'll leave that for now. And then I'll just grab this drop again, so we can drop description. Okay, and then let's take a look at it again. Okay, I feel like we're getting closer. Do you have any other questions before we try to fit a model? Like anything else you think we should take?
One thing I would want to do is, because we kind of like made this description length thing on the fly, I would kind of want to verify that that is indeed an integer rather than a string, because like who knows what data type these random functions that we were just Googling it was throwing out. So I would probably want to look at the info again just to make sure that we know for that description length. Cool, it's a float.
That looks good. The other thing, one thing that I might look at before we get started is, first of all, for some of these categorical variables like parking options and region, I'm curious how many different values there are, because if there's like 1,000 different values, we're still gonna end up with like a lot of parameters in this model.
Right.
So one thing I might do is just like, we can even do, is it describe? Give us a little bit more, or allow us to get this a little bit faster. So region,
there's 404 different categories.
Right. So we probably don't want to throw that into the model willy-nilly, because we're going to end up with 403 slopes on region if we put that in. It also looks like, oh, well, actually that's an and for reason. There's 12 different types of apartments. That's a little more reasonable.
How would you go about
51 kind of states?
Yeah, that's interesting. Maybe we could look into that. Maybe Puerto Rico or something is in there. How would you go about kind of verifying that all of these, that there's like no errors in the data of like, oh, maybe laundry options, maybe one of the 5 is like capitalized differently than the others, or like...
Yeah, I would go through, if we were spending more time on this, and I want to make sure we got some time for modeling, but if I was spending more time on this, I would definitely go in much more detail looking at each of these. Like, so for example, let's look at type for a moment, because this has kind of a lot of categories to just throw it into the model, but not so many that we just want to like definitely throw it out. But so one thing I might do is, first of all, take a look at housing.type.value counts. And so this gives me all of the values in this column. So we've got apartment, house, townhouse, condo, duplex, manufactured, goes on. So it looks like these are all at least their own thing.
Right.
We definitely have a couple categories like assisted living and land that don't seem very highly represented in the data. And in fact, like even in-law and flat and loft and cottage cabin are like, there are a lot fewer of those than all of the other ones. So like one thing I might do is, this is a lot of extra parameters for like not that much variation in the data. I might collapse this into one category that's like other.
Interesting.
To just kind of cut this down a little bit. The other thing I might do is take a look at a box plot of all of these things and price. So I might do like SNS.boxplot, X equals type, Y equals price, data equals housing, and then show the plot. Okay, so
It's like there's one massive outlier in
now
apartments.
this is actually okay. Let's investigate this further. So like, it might not even be one outlier.
Sure.
It might be like a bunch, and we
There's
just
a
can't
bunch
even
of $2
tell.
million apartments somewhere.
So one thing I might also look at here is, I guess I'll use. I always forget if we're at histplot or histplot. Seaborn keeps changing. It's or distplot, like, and then do housing dot price. Distplot now. Distplot. Okay, so we've got this like very, very skewed distribution here where we go from 0 all the way up to like 1 million or more than, is the one with
nine
so
zeros.
billion.
So yeah, 2.5 with 9 zeros.
So I think we want to probably restrict this a little bit. Let's, for the moment, I'm going to just kind of arbitrarily cut this down. What do you think is a good like cutoff point?
So we're going to be removing rows where price is over 1 million.
Yeah, or like.
So how would you go about deciding this in like the real world of like, when can you just throw out data like this?
So I guess there's, again, no clear answer. I'm sorry to say, but I think in practice, you kind of play around with this for a little while. So let's like, for example, let's just start without making any permanent changes. Let's actually, we can do this in here. Let's subset this right like within the plot and say we only want values where price is less than 1 million. And then let's like replot this. And it still just looks like super skewed. Like we still really can't see this variation. One thing we could do at this point is we could even try like taking a log and see if like the log transform helps us get something that's like, oh, and then here we're gonna have an issue with taking the log of anything that's 0. So that gives us a clue that there's actually some apartments where the price is 0. So now I'm gonna say like, and housing dot price greater than 0. And I think I need to put these in parentheses. And now, okay, so now we've got like a little bit more usable of a distribution. So this might be a clue that we want a log transform for our price variable, because I threw this log in here, but we could also...
Could we go in the other direction and try like super like overcutting things and just say like, hey, what does it look like if we cut everything that's less than, 2,000 or everything that's greater than $2,000 and see.
Yeah, let's do like 3,000. I feel like because these might be rental prices.
Yeah.
And this is, yeah, so that looks pretty good. This is another thing that we could do instead of just taking log, we could just cut this down and say, okay, like realistically, we really only care about this when we're looking at apartments that are 3,000
within our lowly price range.
Within our lowly price range. Yeah, and then I see somebody wrote in the chat, can we see performance before and after including the outlier? And definitely. So this comes back to a question that somebody asked on Discord a couple weeks ago, and I thought it was a great question, which is like, how do you compare models? And I think totally, if you have a data set where it's not super costly to run or time consuming to run the model, you can definitely like run the same model with a bunch of different iterations, getting rid of an outlier, or getting or like taking a log transform, not taking a log transform. You can try all of those things and refit the model. It gets a little more difficult if you have like a huge data set. Then you might need to like take a subset of data to do that exploration. But yeah, no need to ignore your comment, because it definitely looked like one outlier in that plot that we saw. I think it was just like a weird artifact of the skew, but it definitely looked like an outlier in that first plot. So I would say, based on looking at this, I feel like 3,000 seems like a pretty good cutoff point. I mean, we could like look at this tail
to 10,000 or 5,000.
To like 10,000 and see if it looks like, yeah. I mean, it kind of looks like, to me, the cutoff is maybe like 3,000 or 4,000. So my very precise method for this, I'm going to cut it to 4,000 or smaller. Okay, so let's actually do that. We'll do housing equals housing dot price. Actually, I'll just
totally override it.
I like housing affordable.
Yeah. And that kind of distinction is like, if we saved over housing, then it would be a little bit trickier to say, oh, let's plug in the model before we cut out the super expensive houses. It would be a little bit trickier to do that, or we'd have to like reload the data set and
yeah, for sure. Okay, let's do that. Okay, so now let's just take a look at this again. All right, so we've got region, price, and then I'm reminding myself as well, we looked at this before, we saw region is a little bit overwhelming of a variable right here. Maybe, like, again, I assume that the region is giving us, like, specific cities, basically. Maybe there's a way that we can do some, like, combining of categories again, where we just say, like, northwest, southwest.
Right, maybe we could merge
Central,
this with some database
like,
of
whatever.
like, oh, Jacksonville's in the south and New York is in the northeast.
Yeah. So there's lots more. I guess it's going to feel a little unsatisfying because there's a lot more cleaning of this data set and producing, like, not just cleaning, but creating of new features So like feature engineering that we could do before fitting a model that would probably improve this model. Because to be fair, like the relationship between price and square feet is probably different by region, right? Like the prices in Jacksonville are going to be different than the prices in New York City, and the relationships between like price and other variables might also be different in different regions. So I feel like region is probably important in some sense, but like
yes, I mean, so ultimately we could do the same thing of like depending on the real world application of this. If we're renting an apartment in Denver, we don't really care what rent is like in New York. And so we could take this data set and just like we cut out all the super expensive apartments, we could cut out all the apartments that are not in Denver.
That's also true. Yes. But what if we have apartments that we want to rent out in like every major city in the US?
Yeah, that's a good.
What do we do?
I don't know.
Okay. So let's see. What should we include in our first model? Should we include?
I mean, I think the most obvious things are like square footage, bedrooms.
Yeah. Okay. Let's get a model going. Let me grab this same code from up above. And I'm going to go ahead and start adding. We're going to do this with housing affordable. And let's start grabbing some things. So we'll include type for now. Square feet, beds, baths, cats allowed, dogs allowed.
And remind me of like those are certainly should be treated like a category, right? Of
yeah.
Like, yes, no, but it looks like right now they're treated as like 0, 1.
So remember that. Here, let's actually print out the info again. So all of these are being stored, it looks like, as integers. So it's just 0, 1. And remember that when we fit this model with, say, like type, what's actually happening under the hood is we're getting a new a new design matrix here that has 11 new columns that are ones and zeros. I can actually like print that out. Let's see. I think it's like Patsy dot D matrix. You know what I'm gonna do? I'm gonna go back to, I think it was here. I may have done this. No. Let me try one more place. Matrix representation. Yeah. Okay, so this was a different data set, but let's just for a moment do like rent, or it was price as a function of type, and this is housing affordable, and return it as a data frame. And so yeah, so this is the new X matrix that we get. And so it'll have like this 1 for an intercept, column of 1 for the intercept, and then it'll have like type T assisted living, and this will be ones and zeros. Type T condo, and this will be ones and zeros.
Right.
And so it basically just creates a bunch of dummy variables with ones and zeros for all of the possible values of that categorical variable. So back up here, this column cats allowed is basically the same, is being treated in the same way as this type column. It's just we're not seeing it when we use this OLS from formula. We're just putting in this string, but in order to fit the model, it's separating that column into like 11 new columns.
Got it. But if we had 3, so that's working because it's binary, if it's either cat's allowed or not. But if there was a third category for that, we wouldn't want it to be numerical 0, 1, 2. We would want it to be string 0, 1, 2, which would then be treated as a category.
Exactly.
or the the string, the actual names of those categories, whatever they might be.
Yeah, exactly. That's a good point. So again, if we were being more thorough here, we'd probably want to verify that the only values are zeros and ones. I'm pretty sure I've taken a look at this before and verified that, but definitely would want to. It also seems like all of the columns where it is like a binary thing, like cats can be allowed or not, seems like those are ones and zeros, and anything where the type where there's more than 2 options, it seems to be recorded as strings, but that's an assumption that I'm making. That's not like something that we've checked right now. Okay, let's go back. So we were here. So we had up to smoking allowed in the model. Let's do wheelchair access. I'm just adding everything. I don't know. Vehicle charge. There might be a shortcut to add everything and then take some things out. An R there is, but. And then let's do, what do you think? We'll add description. We'll add Latin long. Let's add description length to start, and then we'll come back and add some more things. And then the data is housing _ affordable, and we're going to fit this model. And then let's print out the summary. It's going to be big, but might take a minute. Okay. So, and I'm actually going to zoom out so that we can see all of this. This is one thing I don't like about the summary output. I would love if they would output it for me as a data frame directly, but instead we get this like crazy thing that is subject to whatever weird formatting Jupyter Notebooks decides to use. Okay, so we can actually see a lot of the things we've already talked about. We can see that the R squared is 0.129 and adjusted R squared is also 0.129. So I would interpret this as like this model is not super good at identifying or at predicting price, because we're really only explaining about like 13% of the variation in price for all of these apartments. But we could use these numbers to compare this to a new model. So let's see what happens. And you'll notice like we do have at least the type variable, like we said, we've got like 11 different values here.
Right.
Let's add in lat and lon and just see if that improves it at all. Because right now we have nothing cutting down the region at all. So maybe that would be useful.
Oh yeah, lat and long is actually a great way to get the region. But that's not going to be like linear, right?
Yeah, it's hard to.
Because it's not like, oh, higher latitude is going to be more expensive. And...
Yeah. Maybe we need like Oh, okay. Let's add it in. Okay, well, it did improve it. I feel like, I mean, for such a small number, like this is only 0.129, so we're already up to like 15%, so that's not terrible. I bet that if we ran like a ANOVA comparing these two models, I bet the bigger model would, like that added complexity would probably be worth it. Other ideas or questions?
Question from the YouTube chat: how do we calculate feature importance?
Oh, that is a very loaded question. So one thing that we can do is if there's something called like what are they called? Standardized coefficients. Another thing that we can do that's slightly different but related is if we standardize all of the quantitative variables, then they're all on the same scale. Then the coefficients at least are all on the same scale, so they are comparable. So we could actually, if everything was standardized, we could compare coefficients at least for the quantitative variables. Another thing that people do, and I guess this is really a plug for the feature engineering content that's coming out hopefully in a couple of months that Nitya is working on, because there are a lot of other mechanisms that we can use to try to like pick out features based off of their relative importance in terms of this model, or there's also ways that we can iteratively try to build this model. For example, like we can use like forward or backward selection to kind of tell the computer, okay, like start with a model that has everything in it and start deleting things and testing them out, and then if something helps to delete it, then keep it missing and then like continue the process from there. Or the reverse, we could start with nothing and try like adding predictors one at a time, and then see which one and do it, which one improves the model the most, and then only keep that one and then iteratively do that again. We could also use like ridge or lasso regression to try to shrink some of the coefficients to zero if they're, or close to zero if they're not super relevant. I see a question. I wonder why stats models doesn't include in summary metrics such as mean absolute error, mean squared error, root mean squared error. Is R squared better? That's an interesting question. So R squared is related to all of those things because it is also based off of the it included in that R squared calculation. You're calculating like the error as part of it and basically saying like how much of that error are you, or how much of the variation are you accounting for by adding that line in. But I don't know. I don't know why they chose not to include additional metrics. It's always interesting. Okay, we are like running quickly out of time, and I know we haven't gotten super far, but at least we've had a chance to test out some models, and hopefully you've all gotten a taste of what this might look like on your own. I think the fun of today is kind of, we didn't have a clear direction of where we were going to go with this today, but it was, I hope useful to kind of see how one might get started on an analysis like this. And my hope is that if you're interested in learning more about linear regression, and if you're interested in practicing these skills a little bit more, that you might take this and run with it and like try running your own model, see if you can improve this even more. Another thing I would probably do is start subsetting the data to one region and see if that allows me to get at least a little bit better.
Yeah. But I think this kind of work in general just will make you more comfortable with using all of these tools, make you more comfortable with like kind of solving arbitrary tasks like we were doing of like, oh, how do I find the length of the string in this column? Just like the more and more work that you do working with data frames, working with these libraries that are making these models, I think that will just help grow your skill in like being able to, or being more confident in doing these when you need to do it in a real world situation.
Yeah. And another thing that I will say is once you have learned more methods for creating models, then you can even, like, you could extend this even further. This doesn't have to be just a linear regression problem. This can be like a how well can I predict price problem.
Right.
And you can try even more methods and use some of the methods that we discussed here to still compare models. And also some of these metrics that Alex in the chat just mentioned. So like mean absolute error is a useful one to compare different types of models, because like you don't necessarily have a way of calculating like AIC for like every type of model that you might create, but mean absolute error you definitely could.
Cool.
Well,
that's it.
That's it for linear regression. I hope that you guys found this helpful, and definitely let us know if you have any more questions. We'll try our best to answer them. And feel free to write those questions as comments in the YouTube video, or also on Discord if you have been on Discord.
Yeah. We don't have any other live streams currently planned, but hopefully we will do another kind of series like this in the near future. But yeah, might take a couple weeks break. So we'll see what happens. But yeah, keep an eye on the YouTube channel for more stuff like this. And yeah, thanks for doing this, Sophie. Sophie led 8 straight weeks of this. So great work, Sophie.
It's all fun. Thanks for joining me on all of these, Alex. This is a wild ride.
Yeah.
All right.
Cool.